Hello, Algebra 1. For homework tonight, you are taking notes on a new topic. This topic is solving a quadratic by factoring. Just right off the bat, what I would like you to try to do is, with the knowledge that you currently have, go ahead and pause the video and copy down the problem below. This is example 1a. Please try to find out what values of x work for that equation, and then pause the video. Hit play to see the answer and proceed with your notes. So this problem, x squared minus 2x plus 1, so far I've only shown you how to solve a quadratic using the square root process. So when you do that, you get your x's by themselves, and then you get your constant over on the other side. Now, part of the problem is I cannot take the square root of what's on the left here because x squared is not by itself. I've got this b term that's part of it, and that starts to make things more complicated. And never mind, we have a negative 1 over here on the other side. That doesn't really mean much. Doesn't necessarily mean at this point that we do not have a solution. So it's really difficult to be able to solve that particular problem using factoring. Using the square roots. So instead of using square roots, what I would like to do is to show you how to use factoring in order to solve the problem. But before we do that, let's do another example. And this will be example 1b. Okay. If I said that I have 3 times x equals 0, go ahead and pause the video and try to figure out what does x have to be. So after thinking about it, you see that 3 times x is 0. The only way you're going to get a 0 for your product is if x is 0. You divide by 3 on both sides of the equal sign, and there you go. Now let's make things just slightly more complicated, and let's say we have 2 plus 3 times x equals 0. Again, since my product is 0, one of these, either 2 plus 3 or x, have to be 0 in order for that to be a true statement. I know for sure that 2 plus 3 is not 0. That means x, if I could just get my pen back here, must be 0. Alright. Now, moving along, let's go right back to our x squared minus 2x plus 1. So go ahead and write that down again for example 1d. X squared minus 2x plus 1. And this is example 1d. I'm going to go and finish this off. I said all of that equals 0. What we can do is we can take that and we can factor it. So we have something times something equals 0. And remember, this is a is equal to 1. You've got your PQ here. You see your minus plus situation, and that means you definitely have a minus minus. You have no coefficient of x. This is all from the last benchmark. It's review. And the only way to get 1 is 1 times a 1. You check your work by OIing it. Find the outside and the inside, so that's negative 1x minus x. Add those together and you do get your negative 2x. Alright, so we just checked our work. We know that x minus 1 equals 0, and we know that x minus 1 equals 0, so them multiplied together. So the next thing that we have to do in order to find out what values of x work here is you take your x minus 1 and you set that equal to 0, because that might be 0. Just like we did on this previous problem down here, we said, well, you know, this 2 plus 3 might be 0. Let's say one of those was a variable, 2 plus x. Well, that might be 0. Okay, so back to our current problem. X minus 1 could be 0, so that means x could be 1. And then you take your problem and you take the second half, the other factor, and you multiply that. So you got, not multiply, but you set that equal to 0, and that looks like this. X minus 1 is also equal to 0, so x is 1. So there's only one solution here, x equals 1, in order to make this a true statement. You could plug it in, 1 squared minus 2 times 1 plus 1. Well, that's 1 minus 2 plus 1, and that does equal 0. So that's a true statement. We do have the solution to that quadratic. X must be 1. Okay. We're going to go and do another example. This will be example number 2, so if you need to, pause the video so you can copy that down. Don't forget, I will be collecting these examples tomorrow in class to show that you did your homework. Alright, let's do example, not 1E, excuse me, example number 2. Now, this time we're going to go ahead and do a factoring problem. However, this time it's going to have a is not equal to 1, because most of the cases you see in real life will not have an a of 1. Now I have this problem. So go ahead and take a moment, please, pause the video, try to factor that problem, and then hit play to see how to factor it. So factoring this problem, I know my mn has to be 2, I know my pq has to be 3. So that's a 1, 2, and pq is a 1, 3. That's the only way I can get it. I see a plus plus situation here, which means my binomials are both going to be positive in the middle. There's my x, and then we've got a couple of trials here to try out. Okay, I'm going to try 2 and 1, followed by 3 and 1. So when you OI that, you get 2x, that's my outside terms, plus 3x, which is my inside terms. So when we see we get a 5x, we know that that is not the solution because we're looking for a positive 7x and not a 5x, which means we need to try another trial. Let's keep our 2 and our 1x in the same spot, but let's swap the 1 and the 3. So again, you OI that problem, and you see I have 6x plus 1x, and that gives you your 7x. So that's factored, but we're not quite done yet. So we now have our equals 0. There's going to be 2 different answers here, and one answer is, well, what if 2x plus 1 were equal to 0? And then your other situation is, well then, what if x plus 3 was equal to 0? So there's going to be 2 different answers here. So let's go right back to 2x plus 1 equals 0. You solve that, you see that 2x is equal to negative 1 because you subtract 1 from both sides of your equal sign, and then you divide by 2. I see that x is negative 1/2. Over on the other side, I see x plus 3 equals 0. That means x must be negative 3 to make that a true statement. So those are our 2 answers. X is equal to negative 1/2, and it's also equal to 3. Those are the 2 different answers that will fit. That will, when you plug it in, you will get a 0 for an answer. You could take a moment to try to plug those in, and you can see what you get. Alright, let's go ahead and you can pause the video if you want to copy it down. Otherwise, we have one more example for you. Example number 3. Okay, Algebra 1, we're going to go ahead and continue with our recording with example number 3. In example number 3, I have 4x squared minus 16x plus 15 equals 0. So take a moment, pause the video, please. Try to factor that when a is not equal to 1. Hit play to see the solution. So when I factor this, I've got my mn is equal to 4. I have my PQ, which is equal to 15, and all of this we learned in our last benchmark, last unit of study. MN can be 1, 4 or 2, 2, and for PQ that could be 1, 15 or 3, 5. I have a minus plus situation, which means my answer is going to be negative, negative. That's the only way to get a B term that is negative, and my C term is positive. I write my x's, change back to the pen here, x, x. Then you need to do your trials. Now I see that I have a negative 16 I probably want to stray away from this 115. That 15 would be too big if I multiplied it by 4, so probably wouldn't work out so well. If I multiply by 2, that'd be 30. That's too big as well. So I probably want to have a 3, 5. Now the question is, do I want a 1, 4 or a 2, 2? Well, 2 times 5 is 10. 2 times 3 is 6. That looks like that might be the one that I want. So when you're coming up with your trials, you can use logic to try to come up with the best suitable answer first. Go ahead and OI that. You get 2x times negative 5. That gives you your negative 10x. Okay, and then you finish with the I. That gives you your negative 6x. You OI that, and you do get your negative 16. That's definitely what we want. So I'm going to go ahead and erase this so it doesn't make things too jumbled up and complicated. I'm going to finish the problem because there's my equals 0. Now, we split it up. 2x minus 3 might be equal to 0. The only way to have all of this times all of this to equal 0 is if one of them were equal to 0. So we have to try to figure that out by setting each one equal to 0. So x is equal to 3 halves for this first one. And on the second one, 2x minus 5 equals 0. We add 5 to both sides of the equal sign. So x is equal to 5 halves. So there's our two answers. X is equal to 3 halves, x is equal to 5 halves. That's it. That's all the examples for tonight. That's your new concept. We're going to go and practice this in class tomorrow with some book work and some guided practice.